Mastering iteration. The key to innovation and efficiency. Across disciplines. Discover the essential role of iteration in innovation, programming, and project management through its iterative processes and real-world applications. Understanding the concept of iteration. Definition and etymology. Iteration can be defined as the process of repeating an action or procedure to arrive at a desired outcome. This concept is not only crucial in programming, but also finds applications in various domains such as mathematics, engineering, engineering, and project management. The term iteration is derived from the Latin verb iterum, which translates to again, highlighting the nature of this process as one that involves repetition. In essence, iteration encompasses both the act of repeating a procedure and the resulting output, which can be an improved version of a product or solution. For example, in software development, a program might undergo several iterations, leading to new versions that correct previous bugs and incorporate user suggestions. This iterative process ensures that the software evolves over time, ultimately resulting in a more robust and user-friendly application. Moreover, iterations can also refer to the cycles of testing and refinement that occur in various fields, such as scientific research, where hypotheses are tested repeatedly until they are validated or refuted. Importance of iteration. General applications. The importance of iteration spans many fields, including computer science, mathematics, and project management, primarily due to its efficiency in problem solving. Iterative methods allow for gradual improvement, enabling practitioners to focus on small, incremental changes rather than undertaking complete transformations, which can be resource-intensive and time-consuming. This approach not only saves time, but also reduces costs, making it a preferred strategy in various professional settings. For instance, in project management, teams can apply iterative processes to enhance their workflows and outcomes. By breaking down large tasks into smaller, manageable components, teams can continuously evaluate their progress and adapt their strategies based on real-time feedback. This iterative cycle fosters a more dynamic and flexible environment, ultimately leading to higher quality results and increased stakeholder satisfaction. Furthermore, the iterative approach enables organizations to respond to changing market conditions and evolving customer needs effectively, making it an essential component of modern business strategies. Iteration in programming. Iterative algorithms. In programming, iterative algorithms are fundamental constructs that execute a specific set of instructions repeatedly until a designated condition is met. This is typically achieved through the use of loops, which are programming structures that allow code blocks to run multiple times. Examples of iterative algorithms include popular sorting techniques like merge sort and numerical methods such as Newton's method, both of which rely on repeated calculations to derive final results. Consider a scenario where a developer needs to sum the values in an array. An iterative approach would involve using a for loop to traverse each element of the array, adding each value to a cumulative total until all elements have been processed. This straightforward yet efficient method allows for quick calculations, especially when dealing with large data sets. Additionally, iterative algorithms often serve as the foundation for more complex programming tasks, making them vital for anyone pursuing a career in software development. Iteration in software development Agile methodologies. In the realm of software development, iteration is a cornerstone of Agile methodologies, which promote short cycles of development, testing, and feedback to facilitate continuous improvement. Each iteration, commonly referred to as a sprint, culminates in a potentially shippable product increment, allowing development teams to adapt swiftly to changes in requirements and user expectations. Agile frameworks, such as Scrum, emphasize structured iterations that typically last between 2 to 4 weeks, providing a rhythm for development that enhances productivity and team dynamics. A practical example of agile iteration can be observed in the development of a web-based application. The development team breaks down the project into sprints, focusing on specific features for each cycle. At the end of each sprint, they gather user feedback and make necessary adjustments, ensuring that the final product aligns closely with user needs and expectations. This iterative development model not only leads to higher quality software, but also fosters a collaborative environment where team members can contribute their insights and suggestions throughout the process. Iteration versus recursion key. Differences. Understanding the differences between iteration and recursion is vital in the context of programming and algorithm design. Iteration typically employs loops to repeat a set of instructions, whereas recursion involves functions that call themselves to solve smaller instances of a problem. One notable distinction is that iteration generally requires advanced knowledge of the number of repetitions, often managed through counters or conditions, while recursion can operate without such explicit constraints. For example, calculating the Fibonacci sequence can be performed using both methods. The iterative approach uses a loop to compute each number in the sequence based on the previous two, while the recursive method involves a function that calls itself with smaller index values until it reaches the base case. Although both techniques can yield the same results, iteration is often more memory efficient, as it does not incur the overhead associated with multiple stack frames created by recursive calls. Understanding these differences helps developers choose the right approach based on the specific requirements and constraints of their projects. Benefits of iterative processes: problem solving and project management. The benefits of employing iterative processes in project management are substantial, as they enable continuous improvement and adaptability throughout a project's lifecycle. Teams can revisit and refine their strategies, leading to more effective outcomes and higher quality deliverables. This iterative approach enhances collaboration by involving stakeholders in each cycle, facilitating better communication and a shared understanding of project goals and challenges. For instance, in the development of a new marketing strategy, an iterative approach allows the team to test various tactics and analyze their effectiveness in real time. By gathering data after each iteration, the team can make informed adjustments to their strategies, optimizing their efforts and maximizing the impact of their campaigns. This responsiveness not only increases the likelihood of success, but also fosters a culture of innovation, where team members feel empowered to experiment and suggest new ideas. Iteration in design, iterative design processes. Iterative design is a process characterized by the repetition of design phases to enhance product features and usability. It emphasizes the importance of prototyping and user feedback, leading to the development of products that are more aligned with user needs and preferences. Tools such as wireframes and mockups are integral to the iterative design process, allowing designers to make quick adjustments based on user input and to visualize changes effectively. For example, in the creation of a new mobile application, designers might start with a basic prototype to gather initial feedback from users. Based on this feedback, they can refine the app's interface and functionality, creating a new version that better meets user expectations. This cycle of feedback and improvement continues until the final product is achieved, resulting in a user-centered design that enhances overall satisfaction. Additionally, iterative design promotes creativity, as designers can explore different concepts and solutions without the fear of making irreversible changes. Iterative testing. Software. Quality improvement. Iterative testing is a critical aspect of software development that involves repeated cycles of testing to identify and rectify defects early in the development process. This systematic approach ensures that issues are addressed incrementally, leading to higher software quality and reliability. Many development teams adopt continuous integration practices that often incorporate iterative testing to streamline their workflows and enhance overall efficiency. For instance, in the development of a large-scale software application, a team may implement an iterative testing strategy where new features are tested in short cycles. Each cycle focuses on specific functionalities, allowing the team to identify bugs and gather user feedback promptly. This proactive approach not only improves the quality of the software, but also reduces the risk of significant issues arising during later stages of development. By addressing defects early and continuously refining the product, teams can deliver a more polished final product that meets user expectations. Mathematical iteration, iterative methods. In mathematics, iterative methods are essential for approximating solutions to complex problems that may not have straightforward, closed-form solutions. Techniques like Newton's method are widely employed to solve equations and optimization problems, providing increasingly accurate results through repeated applications of a function. The iterative processes in mathematics often lead to convergence, where successive iterations yield stable and reliable results, enhancing the integrity of computations. A specific example can be found in the calculation of the square root of a number using an iterative method. Starting with an initial guess, the method refines this estimate through repeated calculations until the result converges to the actual square root. Such iterative techniques are invaluable in fields such as engineering and physics, where precise calculations are crucial for designing systems and understanding complex phenomena. Real-world examples of iteration. Practical applications. Iteration is a prevalent concept across many real-world applications, particularly in scientific research, where hypotheses are continually refined through rigorous experimentation and analysis. Historical examples, such as the evolution of the bicycle, illustrate how iterative processes can lead to significant advancements, as numerous design iterations were tested and improved upon throughout the 19th century. In the business sector, companies frequently employ iterative practices to adjust their strategies based on market feedback, ensuring they remain competitive and responsive to consumer demands. For instance, in the tech industry, companies like Google often use iterative processes to enhance their products, incorporating user feedback from each iteration to create more appealing and functional applications. Such practices not only result in better products, but also foster a culture of innovation within the organization, where employees are encouraged to experiment and iterate on ideas. This iterative approach can lead to the development of groundbreaking technologies and services that significantly impact users' lives. The significance of iteration in innovation. Recap and significance. Iteration is a fundamental concept across a wide array of fields, serving as a catalyst for innovation, efficiency, and effective problem solving. Its versatility makes it indispensable in both theoretical and practical applications, allowing for gradual improvements and refinements that can lead to significant breakthroughs. By fostering a culture of experimentation and learning from failures, iteration encourages creativity and exploration, enabling teams to innovate without the fear of making mistakes. Additionally, embracing iterative processes can drive organizations toward greater adaptability in an ever-changing landscape. As industries evolve and consumer preferences shift, the ability to iterate quickly and effectively can provide a competitive edge. allowing businesses to respond to challenges and seize opportunities as they arise. This iterative mindset not only enhances product quality, but also fosters a dynamic organizational culture that values continuous improvement and collaboration.